Algebra 2, Chapter 9, Section 2. Graphing inverse variations. Okay, what are we going to do in this section? We're going to learn to graph inverse variations and the translations of that. In this section, we're going to learn about branches. Okay, so first, let's just look at the example in the notes. Graphing an inverse relation. I'm going to zoom in and we're just going to talk through this. Draw a graph of y equals 6 over x. So what are our restrictions on x right here? Well, we know x cannot equal 0, correct? Okay, so we know x cannot equal 0. So that's going to give us our asymptotes right there. So if x cannot equal to 0, what will y never be able to equal as well? Y will never be able to equal 0 as well. So that is going to end up being our horizontal and vertical asymptotes. Okay. Y equal to 0 and x equal to 0. So plug in points on positive and negative for x. Alright, so you can see the chart there. We plot the points. And what do you notice about the graph? Alright, we've got two distinct branches. The graph has two parts, and each part is called a branch. The x-axis is the horizontal asymptote, and the y-axis is the vertical asymptote. So this is what an inverse variation would look like when we graph it. All right, so let's look. So draw a graph of y equals 16 over x. So let's just pick some points. So in y, well, let's do x and y. So I got y equals 16 over x. So x and y. We know x cannot equal 0. And we know y cannot equal 0. So this is in points of 2. So when x is 2, y would be 8. When x is negative 2, y would be negative 8. So x is 2, y is 8. So c's out. X is 2, y is 8. X is negative 2, y is negative 8. When x is 2, so b is out. X is 2, y is 8. So that looks good. X is negative 2, y would be negative 8. So d is no good. So the answer would be A. So how do we do this? Again, we just got to plot points, both sides of the vertical asymptote. Okay, next example. A function must be defined for all values of its domain. Since k over x is not defined for x equals 0, 0 is not included in the domain of the inverse variation of y equals k over x. The domain is all non-zero real numbers. When k is positive, think about this, when k is positive, the branch of y over k is in quadrant 1 and 3. Alright, so there's quadrant 1, there's quadrant 2, there's quadrant 3, and there's quadrant 4. So when k is positive, it's going to be in quadrant 1 or 3. So what do you think about when k is negative? It's probably going to be 2 and 4. So compare the graphs. Let's erase everything on here. Compare the graphs of y equals 4 over x and y equals 9 over x. What points are closest toward the origin? Alright. The red one is y equals 4x. The axes are asymptotes for both graphs. Both graphs are symmetric with respect to y equals to x and y equals negative x. The branches of y equal 4 over x are closer than the axes, and the branch of y equals 9 over x. The intersections of the graph with y equals x are square root of k, k, and negative square root of k, negative square root of k, where k is the constant of variation. These points are 2, 2, and negative 2, negative 2. 3, 3, and negative 3, negative 3. Okay, so let's repeat that again. The branches are closest when our x and y values are the same along this axis. So square root of k, negative square root of k, negative square root of k. Okay? When k is negative, the branches are in quadrants 2 and 4. That would be quadrants 2 and 4. Compare the graph of y equals 1 over x and y equals negative 1 over x. Okay, since my k value is negative, that's going to be in quadrants 2 and 4. And positive, it's going to be in quadrants 1 and 3. The axes are asymptotes for growth graphs, and both graphs are symmetric with respect to x equals y. Okay. Let's look at the next example. Let's talk about translation. All right. So the graph at the right shows the parent function y equals 4 over x in red. So let's just zoom in on that. Okay. And the two translations, the one in blue is y equals 4 over x minus 2. So what do you notice that did? It shifted our graph to the right 2 units, just like our h value did before. So it was on the horizontal or the vertical axis, and now it moved over 2 units. All right, let's look at the next one. And the green one is y equals 4 over x plus 4. So that should translate us 4 units to the left. So let's look if our green one did that from the axis 2, 4. It sure did. So what do you notice? Whatever our h value is, our x minus h value, is also going to be our vertical asymptote. Okay? So anything on the denominator with the x is going to be, translates us to the left or right, and it's going to be our vertical asymptote. All right, now let's look at another one. The graph at the right here shows the parent function of y equals 4 over x, and the two translations, y equals 4 over x plus 2 and y equals 4 over x minus 4. So let's look at the plus 2 one. So, all right, the red one's our parent function, and then the blue one is y 4 over x plus 2. So what do you think that did? Just like, we can't call it our k value now, but it translated it up 2 units. So now our horizontal asymptote is positive 2. And the green one, all right, our horizontal asymptote is negative 4. So you notice, you can see that, the green one right here, I'll highlight it in yellow. Okay, the vertical asymptote is still x equals 0, and my horizontal asymptote is y equals negative 4. So let's talk about that. The translations of inverse functions. The graph of y equals k, that's our constant of inverse variation, of x minus b plus c, is a translation of the parent function of y equals k over x, b units horizontally, and c units in this case vertically. The vertical asymptotes are x equals to b and c. Okay? So let's look at the graph translation, see if this makes sense. So graph y equals 1 over x minus 2 minus 3. So this tells me we're going to move 2 units to the right because of that, and 3 units down from the parent function of y equals 1 over x. So we could graph y equals 1 over x if we wanted to. And then once we did, we would just move it from the point of origin 2 units to the right, 1, 2, 3 units down, 1, 2, 3. See how they did that? Move it 2 units to the right, 1, 2, down 3, 1, 2, 3. And they drew the exact same graph. Okay, so you could just translate y equals 1 over x, and then translate everything 2 units to the right and 3 units down. Okay, next example. Find the asymptotes and sketch the graph of y equals negative 1 x plus 7 minus 3. Well, we know it's going to be in quadrants 2 and 4. Okay, our horizontal asymptote is going to be negative 3. So y equals negative 3 is going to be the vertical, or sorry, the horizontal asymptote. All right, and x equals negative 7 is going to be the vertical asymptote. So x equals negative 7, y equals 3. So a's out, and d's out. Okay, so which way are we going to move? We're going to move 3 units down and 7 units to the left. So from the origin, 3 units down, 7 units to the left. So the answer's got to be B. Okay, writing the equation of a translation. Write an equation for the translation of y equals 5 over x that has an asymptote at x equals -2. So here's our graph. X equals -2 and y equals 3. So we need to translate it 2 units to the left and 3 units up. So we can rewrite this as y equals x, or 5 over x plus 2 plus 3. We need to go 2 units to the left, so x minus -2, or x plus 2, 3 units up. Outside everything plus 3. Okay, 6a. Write an equation for translation of y equals -1 over x that is 4 units to the left and 5 units up. So that'd be -1 over x. Our h is going to go to the left. So we're going to say minus -4, so x plus 4. And then 5 units up, plus 5 on the outside. So the answer is C. Okay, 6b says graph the solution. So we need 4 units to the left and 5 units up. 4 units to the left, 5 units up. It's a -1, so it's going to be in that quadrant. So C is good. A is in the wrong spot. B is in the wrong spot. And D is in the wrong spot. So the only possible answer is C. All right, and that concludes this section.